This highway interchange in December 2021 illustrates the physical impact of Tropical Depression 29W. The storm stalled over Selangor and Pahang, isolating entire urban sectors under feet of brown water. This chart shows the 6.1 billion ringgit in economic damage caused by those floods. To put that in perspective, a single storm sequence wiped out 0.4% of Malaysia's total GDP. The underlying crisis is the insurance gap. Out of that 6.1 billion ringgit loss, roughly 3.9 billion was entirely uninsured. For thousands of people, this meant direct financial ruin. When urban drainage systems failed, water filled ground floor apartments and underground parking garages, destroying personal property and vehicles that were not covered by insurance policies. Beyond the cities, maritime supply chains and the agricultural sector came to a standstill. These floods halted palm oil production and paddy harvests, adding secondary shockwaves to the national economy. Malaysia's position on the equator usually provides a natural shield from direct typhoons, yet these indirect systems are triggering financial collapses on a scale typically seen with major landfalls. Historically, geography was Malaysia's best defense. Proximity to the equator served as a barrier that major storms rarely crossed. This diagram shows the Coriolis force, the rotational effect that gives storms their structure. Because this force is weakest at the equator, low-pressure systems traditionally lack the spin required to mature into full-scale typhoons within Malaysian airspace. That geographic immunity is fading. Shifting climate patterns are overriding the natural equatorial shield, exposing the economy to intensified weather systems. Tropical cyclones require sea surface temperatures of at least 26.5 degrees Celsius to form. As the oceans warm, these systems gain more potential energy. The warming ocean acts as a thermal engine, funneling excess heat energy into forming depressions and increasing their rainfall capacity. This excess energy allows storms to develop outside their traditional corridors. High wind shears are now appearing in areas previously considered safe from cyclonic activity. In 2001, Tropical Storm Vamay formed just 1.5 degrees north of the equator. This rare anomaly bypassed traditional meteorological models to strike Johor directly. Historical data no longer provides an accurate map for the future. Relying on past patterns and a warming climate leaves the economy vulnerable to the next unexpected landfall. Malaysia's vulnerability is split between two distinct regions: direct wind threats in Sabah and Sarawak, and massive rainfall in the peninsula. In East Malaysia, the danger is direct and physical. Tropical Storm Greg devastated Sabah in 1996, using high-velocity winds and mudslides to destroy thousands of homes. On the peninsula, the destruction takes a different form. In cities like Kuala Lumpur, economic damage stems from extreme water volume rather than wind speed. The massive inland losses occur when cyclonic systems interact with the region's existing weather patterns. A cyclonic system pulls massive moisture inland until it collides with the northeast monsoon over the Klang Valley. This collision creates a deluge that instantly overwhelms urban drainage capacities. When pipes hit their limit, runoff floods high-value sectors. These multi-billion ringgit losses occur when rigid urban engineering collapses under the combined weight of a cyclone and a monsoon. We cannot stop a typhoon from forming or dictate the path it takes once it begins to move toward land. While limiting global warming remains critical, Malaysia's survival depends on aggressive physical adaptation at home. The first line of defense for coastal regions involves the legal protection of nature-based barriers. Mangrove forests like these along the coast act as biological shock absorbers. Their complex root systems dissipate wave energy more effectively than concrete seawalls. In urban centers like Penang and Kuala Lumpur, the focus must shift to upgrading hydrological engineering. Implementing sponge city concepts can mitigate flood risk. Permeable pavements and underground retention units trap rainfall before it ever reaches a saturated river basin. Treating these storms as an engineering challenge allows Malaysia to close its insurance gap and fortify its infrastructure against a warming climate.